Hey everyone! Well, the day has finally arrived. I'm really excited about today's video. As you might have already guessed, that's right, I'm going to be adding 3 additional inches of clearance under the gantry on my Shapeoko 5 Pro. And I'm going to be using this aluminum rectangular tube to get the job done. So let me take you in a little closer and I'll explain exactly how it is that I'm going to go about doing it without changing anything to the machine, meaning I won't have to relocate my bit setter, I won't have to worry about changing the geometry of the machine, none of that. So let me get you in a little closer and show you how I'm going to do it. Alright, so my plan is to loosen all 8 of the screws on either side of the machine and free up the machine from the hybrid table. And then what I'm going to do is I'm going to insert this 3-inch tall by 4-inch rectangular tube. There's 2 of them together here. I've got this set up already to be machined. I'll explain that in a second. So I'm going to place one of these rectangular tubes on either side just below this part here where there's a seam right there, and I'm going to lift up the machine from the table and create an additional 3 inches of clearance under the gantry. And the reason that I'm doing that is because currently the gantry right to this lowest point only has 4 1/4 inches of clearance. The machine's Z-axis can travel 6 inches up and down. So if you wanted to utilize that, you can't, because let's say you have a 6-inch block of wood and it's really wide. You won't be able to clear it with the machine itself as you're trying to work on it. You'll bang into it and you won't get past it. So what I'm going to do is elevate it, so I will now have 7 1/4 inches with a little bit of room above it, and if I have a project where I need to come down lower, I can always move the spindle mount on the Z-axis, bring it down a little lower, and get closer to the surface if I need to. I never cut into the surface of the table itself, so for me it doesn't matter. I always put some kind of sacrificial material underneath it, so I will come up a little higher and it should be fine for me. So let me go over the material itself. What I've got here is 3-inch by 4-inch by 50 inches long aluminum tubing, and it's a 1/4 inch wall thickness. So there's the 1/4 inch wall thickness. This camera just wouldn't pick it up. Sorry about that, but all right. So this is how it came to me from the supplier where I got it from. And right off the bat, it's extruded aluminum, so it is not exactly square. I'm gonna try again, see if I can get the camera to pick it up. But as you can tell, it's not exactly flat. So it's kind of arched in the center of both tubes. You can see the center is high and the edges are low. So I have to machine both sides of the aluminum to get it flat, and they must be exactly parallel to each other, the top surface and the bottom surface. And we're going to use the machine to do that, of course. But this is a little bit of a tricky setup, being that this tube is 50 inches long and the machine can only cut to 48 inches. I have to cheat it a little bit. So I'm going to be using an oversized cutter to do that task, which is to get me a little bit farther out. And what I'm going to be using is this aluminum face mill end mill. This one happens to be 2.5 inches in diameter. And it also has, I can see if the camera will get it yet. I'll try to pick it up there for you. But the cutters themselves are on an angle. There we go. So they are not flat with the surface. This is only for aluminum. And you couldn't use this to try to, you shouldn't use it to try to surface your table, things like that, nor should you try to use a surfacing bit that is for wood for aluminum. And what I'll do is I'll make multiple passes across the surface, taking a little bit off each time, and then flip it over, do the same thing to the other side, and it should be dead flat once I've done that. All right, so let me get this set up. I'm also going to take you over real quick to the software, and I'm going to show you really fast the program that I drew up to do this, and then we'll come right back to the machine and we'll start machining it. All right, everyone, so we're here in Vectric, and I have my job already set up for the aluminum tube that we're going to be cutting. Remember, keep in mind the tube, as I'm going to be doing it, they are 50 inches long. They're 4 inches wide a piece, and I've bunched them together, so it'll be a total of 8 inches. And the reason I did that is because I have to cut this as one piece so that the two tubes are exactly identical from one side to the other. If I cut them separately, they will probably come out slightly different and can't have that. So I will be cutting this as one piece. And they also have a thickness of just over 3 inches. And so what I've done here is I've created this inner line right here is the actual aluminum. All right. And this line represents my X, Y, and Z 0. All right. So I'm going with a 1 inch offset on that, because this would be 50 inches all the way out to here, and the machine will not be able to zero from the corner. So I had to do a 1 inch offset on the XYZ set point. So that's why this is here. Now, to reach all the way out, like I said, out to 50 inches, I'm going to be using a 2.5 inch bit, and from this point, which represents the 48 inch mark, the bit will then reach over with its radius another 1.25 inches, and I'll be able to cut just past the edge of the aluminum. All right. And in order to do that, I set up a rectangle outside of the perimeter. That's what this line represents, going all the way around. All right. So I drew another rectangle larger than the piece, and that is what the tool paths will be based off of. And the reason for that is so that I can get outside of the dimension of this 50 inches, and it'll allow me to cut it entirely. So let me show you. Well, I'll flip over now to the toolpaths section. And the way I did this is I select this outside perimeter, and then I go in and I use the pocket toolpath. And under the pocket toolpath, I'm able, I'll actually show you the first one. So I'm going to be starting at the surface of the material, and the first pass will have a cut depth of 8 thousandths. And I'm just going to try to touch off and see, because again, the surface is arched, it's not flat. And I want to just be able to hit the high points and see where it's at. For the tools, I'm going to be using an aluminum face mill, and that I have, it's a 4-wing cutter with carbide inserts. It's 2.5 inches in diameter. I will be using a step over of 1/2 inch on that particular bit. The spindle speed is the lowest I can go, which is 6,000 RPM. And I'll be feeding it at 30 inches a minute, and that will see how that works out on the machine. It has a range that comes with it, the instructions, that you can go anywhere from 25 to, I believe it's 60 inches per minute. So I'm going to just start out at 30 and see how it goes. I'm also using a plunge rate of 30 inches per minute as well. And this bit, they recommend that you ramp in on it. I'm not starting exactly on the surface outside of it, so I'm not concerned. And only at 8 thousandths, I'm not too particularly afraid to skip using the ramp in. All right, so that's the tool. I'm going to be using a raster cutting pattern here for this because I want it to go, it's going to start from here and work its way back and forth from the outside of the piece. If I had used the offset, it would start in the center, and I don't want that. There's no raster angle, it's 0 degrees. We're just cutting left to right, horizontal with the material. And yeah, so that's it for the setup of it. And that first pass is 8 thousandths deep, and then each consecutive pass, as I need them, is an additional 5 thousandths deeper. Each one, same tool setting, same everything, just they are additionally 5 thousandths of an inch deeper until I have completely face milled the aluminum and there's no missed spots in it. So I will run the first one and show you how that will go. And there you have it. So as you can see on the edges here, it's just getting past the edge of the tube. I hope that comes up on the screen. It's very faint, but and there you go. All right, so that gets the entire surface. And again, that's because of the diameter of the bit, the 2.5 inch diameter bit. Okay, so that's it for the design and the tool paths. Now I'll take you back on the machine and we'll start machining it. And I'll go over again just in case it's not clear, exactly how I will achieve getting the entire 50 inches going across. So, all right, I'll see you guys at the machine. Okay, so I'm back over at the machine, and in case it wasn't clear as to how I'm going to achieve cutting the 50 inches, I've already inserted the bit into the spindle, and if you'll notice, the first pencil mark, this one right here, is my 0. That's my X, Y, and Z 0 right there. This is the absolute limit of the machine, and so I have it set here, and the cutter will just make it past the edge of the aluminum tube, so we should be good. And that's how I'm going to reach out another inch or inch and a quarter or so and obtain the 50 inch that we need to surface mill this tube. All right, so let me now get started on the first pass. All right, so here it is after the first pass. I only went 8/1000ths deep on this first pass, and you can see just how unflat it was as it came. You know, this is a valley right here, and yeah, so there's a lot more to be taken off. The middle's a little bit better. This end, it does the same thing. This is a valley right here, and on the outside edges as well. So the next pass will take off another 5 thou, and we'll see just how close it gets, if it's enough. If not, each subsequent pass will take off an additional 5/1000ths every time. All right, so let's try the second pass. All right, so here it is after the second pass, and it has, you know, hit the entire surface this time. So I only went down a total of 13 thou, and it you know, got it entirely flat. As you can see, there's no gaps. I'm gonna try to capture that again. It's hard to see in the light, you know. But yeah, no gaps anywhere. It is completely flat going all the way across. There's a little bit of like debris on the surface still. You know, this is without lubrication, so it's galling a little bit. No big deal. I'll just go over that after and remove it by hand. But I'm really impressed. It came out really flat. So all right, so I'm going to now take it out, flip it over, and do the same process to the other side. And again, I have it, I didn't know if I showed it before, but I have it clamped from the ends, keeping it together as one unit so that both pieces will be identical to each other from end to end, crossways. You know, it'll be perfectly parallel to each other. So, all right, let me flip it over. I'll do the second side, and then I will show you guys after that what's coming up next. Okay, everyone, so here are the tubes after I've machined them. I've cleaned them up a bit. There was a little bit of galling on the surface where some of the material, you know, got stuck. And so I just went over it with a really fine sandpaper on a block to just clean it up and make it smooth, so to speak. And I dressed up the edges with a wire brush just to kind of give it like an aesthetic look. I don't plan on, you know, cutting the sides, so that won't be an issue. And now I am ready to loosen all of the bolts on both sides of the machine, and I will then lift up the machine, put the aluminum tubes in their place, and mark for the screw hole locations, so I can then take it over to the drill press and drill the holes out for the screws. All right, so let me show you that. So I also want to point out that I'm also going to be using these end plugs to give the end of the tube a nice finished look, like you can see here. So it kind of looks like, you know, something that would have come from the factory. So I picked these up off of Amazon, and I just trimmed them a little bit to fit, and they just snap into place. Gives it a nice look. Okay, so I've taken out the screws from one side. I won't be needing these anymore. I'm going to go ahead and do the other side. I have new screws to replace them, so I'll show you that a little later on. Okay, so I've got the rails in place, and right now I'm going to go around and I'm going to use a center punch to locate the center of each hole, and then I'm going to drill it out on the drill press. I've chosen to do it on the drill press only because it's faster, and I didn't want to do it on the machine. I don't have a 4-inch long end mill to go all the way through the tube, so I'm going to do it on the drill press. And also, even on the drill press, I'm going to have to do it in 2 steps because my quill only has 2.5 inches of travel, I believe, so I will have to lower the bit on the second pass and go all the way through. All right, so I will mark all the holes, center punch them, and then I'll drill them out on the drill press. So I'll see you at the drill press. Okay, so I've finished drilling them out on the drill press. I got all 16 holes all the way down on both sides. And so now I also picked up a set of longer bolts on Amazon, and these are the same bolts as the factory, just much longer, same style Allen head. So I will put the tubes back in their place, screw it down, and re-square the machine, and then I will join you back. All right, so here it is, all put back together, squared up, and ready to cut something. I'm really excited. I love the way that it turned out. I've been wanting to do this for a really long time, and the only thing holding me back was getting the aluminum. So just to go over it again, I now have, from the point of the lowest point of the Z-axis to the table, I have 7 inches of clearance, and I still have from the inside of the aluminum to the other side, I have 48.5 inches of width. I also did not have to do anything, like I said, with the bit setter. That is still in its original location. Nothing has changed on the machine. I literally just lifted it up off of the table, so it affects really nothing. And again, the other thing too was that I know that there are companies out there that produce 2-inch risers, I believe, that go here to lift up the gantry. And I didn't go with that only because I don't want to change the geometry of the machine. I don't want to put this higher and then end up with like a teeter-tottering situation under stress. If the machine's really pushed hard, will that really be able to hold up? The other issue that you'll have doing that as well is bit setter. because now you're going to have a different height and you'll have to put a spacer on this as well. So to avoid all of that, I really wanted something rigid, and believe it or not, this addition to the machine has also really made the table even more rigid than it already was. I noticed it immediately. So I'm really looking forward to the first cuts on this machine. It should be really exciting. So with that, I will tell you to stay tuned to the next video. Should be in about 2 weeks. I'm going to be cutting something really large, so we'll take advantage of this. That was the idea behind it, and I will look forward to it. So with that, if you guys enjoyed the video, please give me a like, thumbs up, hit the subscribe button, and until then, I will see you guys on the next one.